I'm Molly Brown, University of Maryland,
I'm Kathryn Grace from University of Minnesota.
and we're going to talk about drought and food security today. This is the talk that we are going to be giving, and we are representing the Digital Farming Systems Consortium, which is funded by USAID and is led by Kansas State University. A little bit about the Digital Farming Consortium, which it is a group of very diverse researchers who are working on improving our ability to provide relevant and effective information for researchers in 3 different countries around the world. And in general, what we're doing is looking at examples of innovation of resilient farming systems in West Africa and in Asia. And we're going to be providing information which is derived from crop modeling and livestock modeling and land allocation. But what we will be talking about today is the human nutrition and social component. So a overview of the talk. First, I am going to be discussing and giving a little bit of overview about what a drought is, different kinds of drought, defining food security, and present a little bit of research about the drivers of acute malnutrition. And then I'm going to hand it over to Kat, who will give a case study on Mali and discuss applications of the research in the real world. So what is drought? Drought is an extreme environmental condition that's characterized by the absence of precipitation in the local and regional water cycle, which is the consequence of physical interactions of elements of the atmosphere, hydrosphere, and lithosphere. There's many different kinds of drought, but in this context, we can focus on different temporal scales. So meteorological drought is, say, 2 weeks of below average rainfall. Agricultural drought can be multiple weeks of below average rainfall, which results in reduction in food production and poorly performing crops. And then hydrologic drought is typically multiple seasons, which affect the amount of surface and subsurface water resources, which may affect irrigation of agriculture, because we're interested in food here. So the drought characteristics include the duration, as I mentioned before, that can vary from a week to a few years, the magnitude of this below average period, the intensity. So we could have a very high temperature, very low precipitation, which then affects the impact of the drought, the severity. So if you have multiple years of below average rainfall, it can be extremely severe. A good example was the experience of Cape Town and how it had so little rainfall that the whole urban area almost ran out of water altogether. And then the geographic extent. If it's over a very large area or a very small area, it really makes a big difference on impacts on the food system. Drought is a unique geohazard because it has such a slow onset. A lot of argument about where and when you can say the drought began and when it ended. And it can be very diverse in location and duration. And it's very difficult to measure societal impacts. Some examples of a drought assessment is this. This is the rainfall data which is satellite derived, and it is from this October through December season, a 3-month period, and it's measured as the percent of normal of 1981 to 2010. And you can see that it's been normalized in percent, so that the red areas are 55% of normal or less, and the blue and green areas are above normal amount of rainfall for this last 3 months compared to a historical average. So this is very typical of the kind of rainfall data that we see from satellites. The impact of climate variability can be measured on these various satellite derived products such as rainfall, temperature, soil moisture, and vegetation greenness. And these can be used to track critical thresholds, which are then related to the meteorology, which can then be shown to affect food security. So part of the how we relate the meteorological effect of drought on food security includes the coping capacities of the people involved, local food storage and affordability, local poverty, the amount of food produced, the exposure of a community to waterborne and vectorial diseases, and of course, access to healthcare, food, and markets. A good example of this is my household. That we are having a drought where I live right now, but it has not had much of an impact on my food availability or my access to healthcare because I have a lot of coping capacity and my income is not related to agriculture. But that same level of drought affects my neighbor, who is a farmer, in a very different way. And therefore, it all comes down to that individual factor. To understand how drought and other climatic extremes affect the income and social outcomes of people living in the area where they happen, we need to measure the environmental anomalies from space together with changes in livelihoods. So going back to my example, my household, our income comes from universities and from locations far away from where the drought occurs. But my neighbor, who is a farmer, who gets a large part of his income from farming, he has to pay more for feed, and the value of his animals is lower because they're not as robust as they used to be. And so he has livelihood impacts. And so by looking at our different households and our individual experiences, we can have a better idea of the impact of this climate variability. So here's an example of satellite derived remote sensing. And this is an image showing vegetation greenness from 2020 period, first 10 days of September of this year, compared to the median of 2003 to 2017. And you can see that in 2020, the Sahel was greener than it was during that 2003 to 2017 period. But the Sahel, the Sudanian zone in the mid regions, like in Burkina and northern Nigeria, was browner than average. So you can see also how splotchy this is. Some places have above average, some places have below average, and it varies through time and in space. So when we connect these kinds of data sets to food security, we need to know what food security is. So food security exists when all people at all times have physical, social, and economic access to sufficient and nutritious foods that allow them to have an active and healthy life. This was defined in 1996 by the World Food Summit of the United Nations, and it's been the definition that we've worked on ever since. There are 4 aspects of food security that we consider typically in this kind of research. One is the availability of food, where we have production, distribution, exchange. So that's where agriculture is located, in the availability. Then we have access, which is typically measured on our household. So my household and my neighbor's household, we might have the same available food, but I have a greater ability to buy it than my neighbor. And then we have utilization, where my neighbor might have access to much more nutritious food than I do because I choose to eat noodles and cheese all the time, right? But we both are well because we have a similar access to healthcare. So satellite observations of vegetation and rainfall are very relevant to measuring availability, but they're not very relevant to access or utilization. However, we can ask people about the price of food or your income. So we can both get text messages, and we can provide information about how our income is affected by the drought, and then we can get at that information. Similarly, with utilization, we can ask about, are you well? Have you experienced a problem health-wise? And that it affects stability of utilization. So there are lots of ways of getting information. Some of them are remote, some of them need to ask specific questions of individuals. So we can take all this information and figure out what the impact is. Kathryn and I work on nutrition at the population level or at the individual level because it's very tricky to measure food security directly. So instead, we can look at child growth as an indicator of nutritional status. You can measure child growth or nutrition levels at the prevalence at the population level or at the individual level. You can say, you know, I am above or below average, or my children are. And we often look at children who are under the age of 5 because they're some of the most vulnerable and they respond immediately to changes in consumption of food. There's 3 measures: stunting, which is a longer term estimate of child nutrition; wasting, which is sort of a shorter term estimate in that a child who is perfectly normal can get sick and stop eating for 2 or 3 weeks and then lose a lot of weight, but not be stunted in height. They can recover very rapidly. And a third way of estimating food insecurity or malnutrition is underweight, where you can take the mid-arm circumference. These standards are global and they're based on a sample distribution. There's multiple scales of food security that analysis can be measured. So we have global food availability, which is measured obviously at the global scale; national, where you have imports and production; community level of access, where it's about whether or not the food is actually accessible within your community; and then of course individual and household measures of food security. So a myriad of factors affect the access, availability, and utilization, and they can be measured at multiple scales. So all of these need to be brought into account when looking at food security. So finally, I'm going to talk very briefly about what are the drivers of acute and chronic malnutrition. Some of these are basically, these drivers sometimes are risk factors. So for example, if I was to lose my job and my husband was to lose his job, we would have no income and it wouldn't matter what the weather is, right? Whereas my neighbor, he would still have, access to food. And so the risk factors, there are factors which are factors that contribute to the decline of food security, and some that mitigate, that are actually when you have a new job, for example, you have more income and therefore more likely to be food secure. And then you have inconclusive factors. Majority of studies reported either positive or negative. So sometimes we just don't know. We don't know how that factor affects outcomes. So what we did is we looked at 90 different papers across the literature, and then we summarized them in this figure. So this is my last slide before I hand over the baton to my colleague. Here we can look at the different levels. So here we have child factors like, are you a male or female child, or your age? The younger you are, the more likely you are to be affected by food insecurity. So you can see age is a risk factor, or if you're part of a multiple birth, that never contributes to your improvement. It's usually a risk factor that might affect stunting, wasting, and underweight. Also being sick, like diarrheal diseases, for example. At the household level, the education of your parents, the employment of your parents, the head of the household age, other parameters such as dependency ratio, how many other dependents in the child are in the household, they're pretty inconclusive. Or distance to market. Healthcare access is a mitigating factor. If you have access to healthcare, you're much less likely to be wasted. And finally, you can see here at the region community are estimates of drought from rainfall and temperature, and vegetation index appears. we cannot relate these directly to the individual child because, of course, they are too general, they're too regional in their impact. So basically, I experience the same climate as my neighbor, even though we have very different household and individual risk factors. So at the region community, excessive rainfall, extreme temperature, and drought are all risks for increasing food insecurity, whereas vegetation quality, or excessive growing season rainfall in general is a mitigating factor. And then finally, at the country level, we have gross domestic product, life expectancy, female education, and dietary energy supply is all mitigating factors. And basically, if we know what all these factors are, we can do a better job understanding and figuring out how to implement interventions. Okay, so that is all I have. I'm going to stop sharing and Kat is going to start sharing.
Okay, thank you, Molly. So I turned my timer on so we can make sure we don't go over, but we'll see how I do.
I'm sure we will. I talked for a long time.
Oh, that's okay. You had a lot to say. Okay, let me go back to the beginning. Okay, so I'm going to quickly go through a case study that is set in Mali and relates to a lot, but kind of applies a lot of the different ideas that Molly just shared with how we think about food security, how we think about drought, how we think about the interaction between individuals, communities, and environmental variation, and how we can use remotely sensed data to do that. So hopefully this will give some ideas of sort of the thought processes and the types of issues that come up with this. So the goal of this project is actually both to sort of expand our understanding of actually birth weight and low birth weight. Low birth weight is when a live infant is born weighing less than 2,500 grams. And that's a World Health Organization definition. And when you're born low birth weight, there's all sorts of adverse health outcomes and the short term and long term. So it's a really big focus of a lot of development organizations to try to reduce the low birth weight outcomes. And one of the big reasons for low birth weight is because of exposure to insufficient nutrition while in utero, so during pregnancy period. So we want to understand that and why that happens and where are there opportunities for interventions. But one of the things that we often don't have enough information on is the food security or sort of food access, food availability during pregnancy. So that's what this project is designed to look at. But one of the struggles is trying to figure out how best to use all of that detailed information that Molly was talking about, all the environmental information and climate information with household health surveys. So that's what we're looking at here. So we're trying to figure out the measurement, but we're also trying to understand this variation in low birth weight and how that relates to food and climate variability. Okay, so sorry, for some reason this goofy slide just zipped ahead. Okay, so one of the first, sorry, Molly, and everyone watching, it'll keep you on your toes. Okay, so one of the first things that we have to do when we deal with this, especially when it's sort of across different disciplines, is we have to actually figure out what the pathway is that we're looking at. So in Molly's presentation, she talked a lot about the 4 pillars of food security: access, availability, utilization, and stability. But then we have other things that we have to think about when we're trying to figure out how to merge all this different data. So what we ended up doing, this was a project that we worked on with climate scientists and policy people and demographers and that sort of thing. And so we really needed to come to an agreement on what exactly it was that we were looking at and how we could look at it best. So we made one of these tables, which I think is very helpful for thinking through this, that identified the specific pathways that we thought were at play in our country setting. So we wanted to look at food security or food insecurity. And to do that, we wanted to focus on growing season vegetation. But we didn't want to look at growing season vegetation at the time. We wanted to see what was happening with the hunger season, which happens maybe 9 months later. So after you've run out of food from that year's harvest, but before you've gotten a chance to harvest the next year. So what happens there? So we wanted to think about the severity of the hunger season and how being pregnant during the hunger season would impact birth weight outcomes. So we had to work through that a little bit and realize that we wanted to look at the previous year's growing season conditions, which relates to drought and can be measured with NDVI, a vegetation measure. So we wanted to look at that. We also know that in Mali, our country setting, that disease is a big deal, malaria in particular, and has important impacts, adverse impacts on pregnancy, and is related to the same sort of environmental processes that also are related to agricultural production. And so sometimes those can get all mixed up when we're trying to do these types of analyses, because we can't tell what makes a good growing year also makes a good malarial year. So we were trying to pull those out. So we were looking at rainfall and temperature conditions at the time during the pregnancy as separate from this food security pathway. So we actually constructed a completely different measure using, again, the remotely sensed data. And then we also know heat stress matters, both in terms of drought, but it also matters for biological heat waves matter for biological exposure to heat stress. And that can be particularly bad when you're pregnant, because pregnant women are at greater risk for heat stress than other people. So we just looked at hot days. So all of these measures could be used to analyze drought, and they might work to analyze drought in different settings. But here we were trying to pull apart food production from disease, from heat stress, which can all be lumped together and actually make it quite muddled when we're trying to understand the relationship or how to use these environmental measures. So that was really our big point here. Okay, I'm going to switch slides, and I'm not sure if it's going to do that goofy thing. Oh, I don't know why it's like it wants to do it. Okay, so sorry. So now we're going to talk about the types of data. And we're sorry. So we use different remotely sensed data to capture these things. So there's a bunch of options that we had, different temporal resolutions, different spatial resolutions. And so we selected the ones that made the most sense to capture the thing that we were talking about in our country setting. So NDVI works quite well in places like Mali, which are flat and fairly dry, and dependent primarily on rainfall for agriculture rather than irrigation. So where it's green, we can assume that that's going to be more food production. So that makes sense in this setting, but it might show up a little bit in a different way in a setting like Ethiopia, or in a place like Guatemala, where sort of the patterns of vegetation and the topography and that sort of thing are quite different. So you have to think through that a bit. And then we used rainfall from CHIRPS and temperature from Princeton's reanalysis. Now, an important thing to notice on this slide, which is something that comes up anytime you try to do these types of things using different remotely sensed data sets, is you have different spatial resolutions. So we have 8 kilometers, 5 kilometers, and 50 kilometers that we had to kind of figure out how to use together and how to think through. And we have different temporal resolutions. So those might restrict our analyses in important ways. And we have to also kind of decide maybe which data set to use given the particular time frame that we're looking at. So that's another sort of behind the scenes discussion. And then at the bottom, just to highlight that we used these variables and these data sets in very particular ways to create different variables. So we weren't just doing a monthly average or a yearly average or a yearly max, but we were actually constructing something that really made sense with that pathways table that I told you. So this is really the fundamental part of this sort of research design, how to think through these pieces so that you're actually modeling or capturing the thing that you're most interested in capturing. And it's not just sort of a grab bag of data. Okay, so the survey data that we use, this is the household health data, and this is widely available data. This is the demographic and health survey data. This is geocoded. So the key parts of this is that it's reflective of the entire country, and there's thousands of individuals surveyed, but we only have surveys every couple of years. So the times that this particular data set was used or that we used in this study comes from 2000, 2006, and 2012. And these are geocoded. So that's great. We've got lots of spatial data, but we don't have all of the we don't have monthly data. We don't have lots of detail every year. We just have these big surveys that happened, 5 or so years apart. So we have to work with that. But it gives us a lot of information on individuals. So like Molly was saying, there's big differences between individuals. They might live near each other, but they have very different sort of biological situations, as well as economic or educational backgrounds or any of those things. And what we get from this type of data set is a lot of information on individuals. So we know a lot about the individual pregnant person or their partner or some of their household characteristics. And so we can bring that in because we know from the literature on births and birth outcomes that all of those things matter. So we want to be able to put all of those factors together as we try to understand food security or exposure to drought and what that means for people's health. Okay. So just quickly, I wanted to show you what this looks like visually in terms of putting all this data together. So the survey data, not only do each of the remotely sensed data sets have very different spatial and temporal resolutions, but so does this survey data. So we don't know exactly where any individual lives because that's private. And so we only know the community of residents within 10 kilometers. And there's maybe 100 or more households, it quite varies, 100 or more households that are surveyed within each enumeration area. Within each household, there's at least one pregnant person or has been at least one pregnant person in the past 5 years. There might be more. So we have individuals living in households which within communities, and the community spatial information within 10 kilometers of where it really is. That actually all ends up being okay. But another thing that you have to do when you're kind of working through this and trying to figure out how to merge all of these things is draw a graphic kind of like this, so you can think about where you're going to have to aggregate data. So this big orange guy here, this is our pixel, our temperature pixel, and that's fine. You don't have to do any averaging because temperature is so coarse. But when you do something like NDVI or rainfall, those are much finer. And so sometimes you do have to average because you don't know exactly where that point is, where the community is. So it could be in this pixel, it could be in this pixel. So we just do a 10-kilometer average. And that's fine. That's all doable. It's not a big deal. And what we do too is we know when each pregnancy occurred. And so we can look at the environmental conditions around each pregnancy. So we have an individual who lives in a community. Maybe she had a baby 2 years ago. We know when that conception occurred, when that pregnancy occurred, and where she lived. And so can link all of that to all of that climate information. So we have sort of individual records that we've kind of constructed about climate conditions in pregnancy that we use to analyze those relationships. So that's kind of our big sort of the big contribution of having all this spatial data. Okay, so we put all of this into regression, and modeling is one of those things that I spend a lot of time doing and thinking about, and I won't go into all of that detail here, but we try to bring in as much information about the individual as we can, and we try to think a lot about big questions about spatial autocorrelation and that sort of thing. Try to put all of these into models that help us not so much as predict, but understand the relationships between variables to help us understand why there's variation in certain outcomes. So really quickly, I won't show regression plots. I will show graphics. And what these graphics show us, this is our food security measure. So this is NDVI, our vegetation measure. And these are broken into trimesters. So we see third trimester, second trimester, first, and 0th. We look at that conception period. And what our results show is that when your hunger season is less severe. So when the growing season the year before was good, the hunger season this year is probably less severe. You're less likely to be exposed to food insecurity for a long period of time during the third trimester. Then your baby is heavier at birth. So it's more likely to be healthy when your hunger season is less severe. And that's true for every trimester. For malaria, we looked at disease, and actually this is a bit goofy because what we're seeing is during the third trimester, when more months of the third trimester are malarious, they're ideal conditions for malaria, you actually also see heavier babies. The reason for that is very likely something that we call a selection effect, whereas the weakest babies didn't actually result in live births. The weakest pregnancies did not produce live births. So we would normally capture those, but because of malaria, they've resulted in stillbirths or late term miscarriages or things like that. So they actually don't end up in sort of our live birth sample. So we're not observing those. So we're seeing the heavier, sort of healthier pregnancies or fetuses. Okay, then for heat stress, we see a negative relationship. More hot temperatures are related to lower birth weights, which is what we would expect. Now, if we didn't use our pathways approach, we just wanted to kind of see, does it matter? Do we have to think through these sort of pathways and try and get these measurements right? And so we did an analysis where we pretended like we were ignoring that. We just took an average. What's the average condition during each pregnancy, which is what a lot of people are doing and have done, is just averaging things. And when you do an average temperature during the third trimester, you pretty much get the same results. So you could have just done the average conditions. You didn't have to walk through all these pathways and think about it that way. For temperature. But when you do it for food security or disease, so this is average rainfall. It's just during the third trimester, how much rainfall was there on average over those 3 months. And actually what you see, and remember, rainfall is important for this vegetation measure, and it's also important for malaria. And what you see is two totally different outcomes. So none of these are telling the same story. And this is actually, I think, something that we've seen in the literature is if you're measuring drought or measuring climate variability related to drought, or agricultural variability related to drought. If you don't really get that timing right and think through those pieces, you can get very muddled results that don't make sense conceptually with what we think is happening on the ground. So thinking through this actually helps make sure that our measures are more likely capturing what we want them to do. One of the tricky parts, though, is really thinking about how does this play out in the local context that I'm looking at. So we had to walk through that a lot with Molly, but how does that look in a place like Senegal? How does that look in Ethiopia or in Minnesota? How do we think through those pieces so that we can get those measurements right? So that's a big part of a lot of this. So that's one of our big sort of conclusions, is that specifying the pathway with regard to sort of local conditions and what's going on locally, which goes back to what Molly was talking about with coping strategies and other aspects of the food system that could be impacted, or other things in the sort of health system that could be impacted. If we can think through those and incorporate those into our measurements, then we'll do a better job of sort of understanding these processes. And this seems to be particularly true for things like rainfall and drought. Maybe temperature is a little bit different. But really these rainfall and drought measures rainfall and vegetation measures are not great in the literature. They're kind of all over the place and quite inconsistent. So this might be one way of addressing some of that. And then the other thing is in DVI, thinking sub-seasonally, how much do we know before the end of the season? And if we start using this kind of model to do sort of food security or food aid interventions that are targeted because of indication that the season isn't going to be great and the hunger season next year is going to be severe, then that might be an opportunity to help reduce sort of the risk of low birth weight. Okay. So that is the end of that little case study. And now I have a few questions.
I have a question.
Okay.
Ask other questions. Why don't I start, because you just finished making the point. Can you say a few words about Bangladesh and its extensive, it has a totally different environment, right? So Bangladesh also has DHS data.
Yeah.
They have lots of food insecurity, but they irrigate.
Yeah.
They are green all the time, year in, year out. So what would you say about how you might construct a study there, for example?
Yeah, that's a good question for you too, Molly. I think, where I would start as a person who has not, most of my research has been in sub-Saharan Africa. So thinking about going to a new place and applying some of these ideas would really be to think about and to learn from others what makes a good season. um,
Right.
how are people, what are the constraints that farmers deal with? um, there must be environmental measures related to rainfall or sort of rainfall variability or those types of things that help to make it a good season or a bad season. So can we bring those different types of measures into, so maybe NDVI is not ideal, but
That's what I was thinking. Yeah.
right? But maybe rainfall and irrigation maps and thinking about who gets access to irrigation and how that changes under different sort of climate conditions would be something that you could bring into it.
The other thing I was thinking is you could use rainfall over there, right? Because
Yeah.
the water flows from
Yep.
north to south.
Yeah.
You can say it was a really good rainfall season, or it was huge drought happened up in Nepal and in India, and
Yeah.
we're likely to see less rain coming down and therefore the irrigation water. So what we would need to do is totally transform our observations, and you would have another set of timing. So
Yep. Exactly.
you would have your birth weight timing, and then you would have but what we really care about is not the conditions of rainfall when the baby was in utero, but the growing,
Yep.
the conditions. So it just
You
adds another layer of complexity, but I think it's totally doable.
you would care about the conditions, the environmental conditions that exacerbate the severity, the hunger season. So
Season, right?
what point, what time period influences the hunger season?
And then we could also ask a similar question about, a lot of people ask me, right, but what about like governance and
Yeah.
food aid? I'm like, food aid, really? Good luck with that. I mean, so there's a lot of other things that are going on. And so
Yep.
I do not think, and we are not saying that we're capturing everything.
Yep.
One of the reasons I wanted to show that work about all those different factors is that there's a huge amount of uncertainty.
Yep.
I mean, this stuff is so messy, and a lot of it, like, I would love to have the price of food and the income and all these parameters which really affect, but we can't see any of those.
Yeah. Well, and especially, I think this makes sense more in a rural area than in
Yes.
like the frame. I mean, you still want to think about environmental conditions for people who live in urban areas, but I do think the timing and the process is going to be different than in rural areas. And so
So
that's
your study,
another.
yeah,
And I guess that's kind of the whole take home from our project is a lot of these processes, we haven't really figured out all of these pieces. So there's a lot of science still to be done on how to link these in the best way, all this different data. And there's so much data, but we have to
right.
make sort of very good informed decisions that are informed by experts on the ground and community members on the ground and other science about how to put all of these pieces together, and what model works in one setting doesn't work in a different setting.
Exactly.
So we have to think through that.
Another thing we ought to mention here is with regard to the USAID project we're being funded under and that you're watching this video about, it really, for a lot of the research that folks are doing, for example, in Senegal, they're investing in legume research. And so we can think about, so suppose there's a much higher availability of high quality legumes in the market, or people were able to grow 10 times more magically because of this fantastic research. What impact would that increased protein have on outcome, and can you see diets, and can you pick apart, you know right now what we're doing is we're just going from weather to nutrition outcomes.
Yeah.
So there's a lot of other steps in there that we might want to explore, right? I
And
mean,
the benefit to this approach that I showed is that it's covers the whole country. So we have thousands and thousands of individuals and pregnancies. Whereas some of what you're talking about too can happen when you focus on a community and, or, a smaller area, which is super helpful and important. But DHS data is free. It exists. It gives us sort of insight into, are there communities that look really different? Because we can map some of these things and see, are there places that are really standing out as different,
Right.
and what's going on in those places. So this can be sort of a first look and exploration of the
Right.
relationships, and just to help us dive in and figure out where to go next with it.
That's right. So you had a question for me, and then we can wrap up because I think we're over time.
I'm sure we're over time, but that's okay. I have two questions for you, but my first is easy. I think it's, do you think all types of drought are important to evaluate for human health and food outcomes, or?
Yeah. So again, it comes back down to the pathways approach, right? That you outlined later, is that what really matters is what affects people, that impacts, right? So if you are living in Bangladesh and you have 3 years of poor rainfall upstream, even if your rainfall is perfectly normal, you're going to have big impacts, even though you technically aren't experiencing drought. The drought is somewhere else. And so what matters is what affects the availability and the access and the utilization of food when it comes right down to it. So that's why that framework is super useful.
Good. Okay. Thank you, Molly. My next question for you is, you've done so much work with all sorts of stakeholders on the ground, like
Yeah.
farmers. I mean, you've spent a lot of time with a lot of different experts, even including farmers. Um, how do you feel? What do you think is the best way to engage people in this kind of work? And do you think that's important? And what's the best way to do it?
Yeah, that's a really hard question. And it all comes down to building relationships, basically. And so, what we have found is that you need to do the hard work of getting to know people and to understanding what their problems are, and to coming up with information which is relevant, salient, and believable, coming from the from the right person in order to change the decision. So you and I, we can write 100,000 papers and nothing would ever change on the ground if no one reads them, or people read them but they don't believe it, or they can believe it but it's like 3 years too late. They're like, I wish you told me that 3 years ago. So we have to, it all comes down to the relationships between people and making sure that when you're talking with the physical scientist, you say, okay, well, let's think about what impact this might have, and then who you can tell about that impact to people who are going to be able to use the information today, right? And so it is really tricky and it takes a huge amount of work. And frankly, it's the understanding how to use information is a whole nother job after you create the information. So there's a lot, and it's very complex institutionally as well. So yeah, it's a big question.
Thank you,
Anyway,
Molly.